Here we have a bridge that is over a road, and the highest point on the arch is 5 meters high, and the road is 10 meters wide. So the vertex is at 0, 5, and we know the width of the road is 10. So we know it's got to be 5 from the middle here, and 5 from the middle here. So determine the quadratic function that models the parabolic arch of the bridge. Well, the quadratic function is going to be a quadratic function centered at 0 and 5, and we don't know the vertical expansion value of that. So we don't know a. So we need to find some coordinate on this curve that we know. So we know that at this point 5 meters over, we know that the height of this has to be 4 meters. Okay, so it says that the minimum height above the road is going to be 4 meters, and that point would represent the point at which we would get the minimum height. So we now have a coordinate, and we can then solve for a by plugging in that coordinate. So the key is identifying that blue dot there at 5, 4. So we plug in x is 5. We end up with -1 is equal to 25a, and so we end up with an a value of -1 over 25. So then the equation that of the parabolic arch is going to be y is equal to -1 over 25, and that's same as -0.04 x squared plus 5. Part B says, what's the inequality that represents a space under the bridge in quadrants 1 and 2? So the inequality is going to be when the height is less than 4, sorry, when the height is greater than 4, and it's going to be between those two parts. So the height y, we know that the parabola must be above that height. So that is going to be the inequality that represents the part of the parabola that's going to be above the road. And we can rearrange that, and we end up with this inequality here.